In the garden path project, our primary algebraic goal is to use the quadratic formula or factoring in order to find the value of x. In this problem, x represents the width of a walkway that we are building around a pre-existing garden. As you can see from the diagram here, our garden is represented by the internal rectangle, and then a walkway has been drawn around the outside with the value of x representing the width all the way around. We should recall from our geometry that the area of a rectangle is the length times the width. Now, the information given to us in this problem is that the length of the garden is 16 feet and the width of the garden is 12 feet. And of course, then the area would be 16 times 12, which would be 192, and that would of course be in square feet. Now, we're not going to need to worry about the square foot notation right now. We'll bring that back into the problem at the end. We also know from the problem that Cliff was able to buy a total of 204 square feet of brick. So we know that at most he can use 204 square feet of brick to build his walkway. As I mentioned before, the area of a rectangle is length times width. So now we can look at the area of the larger rectangle that takes into account the walkway all the way around. We know that the length of that larger rectangle is going to be 16 feet for the garden, plus x on one side and x on the other side. So in other words, 16 plus 2x feet long. We also know by the same logic that the width is going to be 12 feet for the garden, plus x feet for the walkway on one side and x feet for the walkway on the other side, for a total of 2x. So the length times the width of our entire garden plus walkway is going to be 16 plus 2x times 12 plus 2x. We also know that the total area is going to be the area of the garden plus the area of the walkway. The area of the garden is 192 square feet, and the area of the walkway is 204 square feet. That means that we have a total of 396 square feet around the outside. We can simplify these two binomials by multiplying them together. 16 plus 2x times 12 plus 2x. We can use a couple of different methods. One of them is called FOIL, which many of you may be familiar with. FOIL stands for first, outside, inside, and last. So I'm going to multiply the 16 times the 12. Those are my first terms. And when I do 16 times 12, I get 192. Then I'm going to multiply 16 times 2x. That gives me 32x. Now I'm going to multiply my inside terms together. That would be 2x times 12 is 24x. And finally, my last terms, 2x times 2x, give me 4x squared. So we now have the equation 192 plus 32x plus 24x plus 4x squared equals 396. We need to simplify this before we can proceed. And when we simplify it, we want to put it in what's called descending order. Descending order is when we put the highest exponent first, combine like terms, and we descend by the exponents. So the highest exponent here is 4x squared. I'm going to write that first. I also notice that 32x plus 24x can be added together. They're like terms. They add up to 56x. And then I'm left with the 192. And that still equals 396. Now, before we can apply the quadratic formula, we have to get our equation equal to 0. You cannot use the quadratic formula unless the quadratic equation is equal to 0. So I'm going to subtract 396 from both sides, like so. When I do that, obviously I get the 0 on this side. I still have my 4x squared plus 56x on the left. And then 192 minus 396 is a minus 204. So I have the equation 4x squared plus 56x minus 204 equals 0. At this point, we could choose to proceed with the quadratic formula, where a would equal 4, b would equal 56, and c would equal negative 204. However, I noticed that each of those three terms, 4x squared, 56x, and minus 204, are all divisible by 4, which means I can actually simplify this problem a little bit, which will make it much more manageable when I use the quadratic formula. So I'm going to divide everything in the equation by 4, like so. And when I do that, I'm left with x squared plus 56 divided by 4 is 14x, minus 204 divided by 4 is 51, and of course 0 divided by any non-zero number always equals 0. So I have the equation x squared plus 14x minus 51 equals 0. Now I'm going to rewrite that on another sheet of paper to make it a little bit easier for us to continue our work. Just rewriting our original equation that we just found, x squared plus 14x minus 51 equals 0. Now we can use the quadratic formula by identifying the values for a, b, and c. Remember, the a is the value in front of the squared term, and if there's nothing there, there really is something there. It's a 1. And so in this case, a equals 1. You can even write that in if it will make you feel more comfortable. The letter b is representing the number in front of the middle term, which in this case is 14, and the letter c represents our constant at the end, which is negative 51. It is very important that you watch your signs. If a, b, or c is negative, then you need to include that negative sign when you're solving the problem. Now, as a reminder, the quadratic formula that we're going to use is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. I know this formula looks a little intimidating to some people, but I want to point something out to you. In this formula, all we're doing is addition and subtraction. We're doing some multiplication. We're doing some division because a fraction bar represents division. We're going to take the square root of a number, and oh yes, we're going to square a number, which means raising it to the second power. All 6 of those operations are simple arithmetic operations. There's just a lot of them, and they're all in one formula, so it looks intimidating, but it's really not. Now what we're going to do is we're simply going to plug in our values for a, b, and c as we go along. So x is going to equal negative b. Well, b is 14, so negative b will be negative 14 plus or minus the square root of b squared. So we're going to put our 14 in there, and it will be squared, minus 4 times a, which is 1, times c, which is negative 51. Now be very careful, don't forget about that sign, divided by 2 times 1. And now that we've replaced all of the letters with numbers, we're going to simplify. So this is negative 14 plus or minus the square root of 14 squared means 14 times 14, which is 196. Now I want you to notice here, we have a minus 4 times 1 times a minus 51. So the minus 4 times the minus 51 is going to give us a plus. And of course, 4 times 51 is 204, all divided by 2 times 1, which is 2. This is coming along very nicely. We continue with the problem. Negative 14 plus or minus the square root of 196 plus 204. Now 196 plus 204 equals 400. And that's all going to be divided again by 2. And we continue, negative 14 plus or minus the square root of 400. Now if this were to come out to be a decimal or something like that, it would be a little bit messier, but in this case, the square root of 400 is a nice number, an integer, it is 20. So we have negative 14 plus or minus 20 over 2. Now this plus or minus symbol is a shortcut symbol we use so that we don't have to do the quadratic formula operation twice. But at this point, we need to break this into 2 separate problems. Negative 14 plus 20 over 2, or negative 14 minus 20 over 2. When we say plus or minus, here you see the plus or minus. And then we're going to simplify both of those fractions to see what we get. Negative 14 plus 20 is a positive 6 over 2, which equals 3. Negative 14 minus 20 is a negative 34 over 2, which equals negative 17. So we actually have two answers. At this point, we need to think about which of our answers makes the most sense. Remember, we're trying to figure out how wide a walkway can be built around our garden. So we're talking about a width, a measure of distance. And distance cannot be negative. You cannot have a garden path that's negative 17 feet. So even though this number would work mathematically, it doesn't really work in the context of the problem, which means the only answer left is 3. So that means that the garden path that we're going to build around our garden will be 3 feet wide.